You may recognize me from some of my past work, such as the line follower, the dragster, or even the bulldozer. I'm here today to talk to you about Group F's design process. I'm here to tell you how we put that beast of a machine in front of you on testing day. During our first brainstorming session, we all sat down and said, what does this robot need to do? Upon further investigation, we found that the robot had to A. Follow a line that featured curves, sharp turns, and intersections, B. Pass underneath an arch and do a 360, and C. Make contact with a brick, circle the brick, and return to following the line. We then thought, what do we need to accomplish these tasks? Our original design featured one color sensor, one touch sensor, and one ultrasonic sensor. The color and touch sensors were mounted on front, with the color facing down and the touch facing out, and the ultrasonic sensor is more towards the back of the robot, facing up. However, in this design, the color sensor had to remain centered over the black line the entire time. We hadn't worked out how it would adjust as the line were to curve or sharply turn. However, during our class discussions, we found that we were allowed to use two color sensors, and this made our lives infinitely easier. With two color sensors, one on the left and one on the right, we could have them on the outside of the line, and that way, as the line would curve, the sensor could detect the line and adjust accordingly. This made our lives so much easier, and this made it onto our final design. We had a color sensor on the left and the right, mounted on the front facing downward, a touch sensor in the middle, also mounted on the front facing out, and an ultrasonic sensor mounted more towards the back of the robot facing up. And though I'd love to sit here and tell you about how it all turned out, I wouldn't want to take that pleasure away from my group members. So, let's let them explain it. Thanks for listening. Thank God.
The process we established in order to complete the line follower project was first for us to decide on our robot design and where to put the sensors. Then we had to work on our pseudocode and decide what the easiest and quickest way to code our robot to complete the course most efficiently would be. Our high priority tasks were to make the robot follow all types of turns and making the brick and bridge portions work consistently. Our low priority tasks were to make the robot the fastest due to the difficulty of staying on the course and making it as consistent as possible. The roles in our group were split up, with Liam and Dan working on the actual code, while Tess and I worked on how to make everything most efficient with the pseudocode, lights, moving around the brick, and taking care of all the videotaping.
Design and test. When we began the design and test part of the project, first and foremost, we made sure to begin coding with many comments. This helped us complete our project successfully because, for example, often on a first period Monday morning class, we would have forgotten what we were working on or aiming to do that last period class the following Thursday. Comments made everything so much clearer and more manageable. In addition, when we began our robot, we did not calibrate right away. Because we were unsure how to calibrate for the black and white colors exactly, we set our own threshold value at approximately 40. This allowed us to gain a basic understanding of line following before we really dove into the project. After these initial steps, the project was divided into stages. First, we calibrated and got the robot to follow the line exactly. This included coding in the required sounds and LCD displays. Next, we attempted to make the robot perform correctly under the arch. Last of all, we did the code for hitting and moving around the brick. As a result of these different stages, we would often comment large chunks of our code so that at times we could focus solely on one specific chunk. For example, we would make the arch all a code. Comment. I meant comment. And then we would just practice the brick code. It was not until a couple of classes before the testing day that we actually put everything together. This project definitely had its hiccups. One problem we encountered was when our robot would continuously enter our arch code. Once the arch would be detected, the robot would spin, but because the robot was spinning under the arch, it would detect the arch again, entering into an endless loop of spinning.
It works sometimes, just depends on where it is in the line.
Our group worked through this problem and decided to drive the robot out about 15 centimeters in front of the arch before beginning that 360-degree turn. This worked perfectly and met requirements. Our second problem occurred when our robot suddenly seemed inept at making sharp turns. The robot would either miss the turn completely and just go straight over it, or it would turn just enough so that both sensors would get stuck going back and forth, switching from black and white on the sharp corner. This caused our robot to jerk rapidly for a good 30 seconds or so before it would complete the turn and carry on. In the end, our group decided to compromise our speed. Although our robot started out speedy, on the testing day he slowed down quite a bit in order to ensure safe turns at sharp corners. One last minor problem we ran into was that first we struggled to code our circle turn around the brick and then refine that line. It took many trials and errors to perfect the number of degrees that we had to travel to clear the brick. Then, with Mr. Malachek's help, we were expertly guided to stop the turn early and then move forward the rest of the way until we detected the line and could start our line following again. Overall, the line follower code took much initial planning and pseudocoding, many testings that called for redesigns and code tweaks, and much patience. But in the end, our robot was a success.
This is the share portion of the video. Our robot performed well in the testing day and no weird errors occurred. The only problem is that on our first turn, the robot did not calibrate correctly and therefore could not find the black line properly. Our second run was flawless and we received the results that we expected. We did not get bonus points for being the fastest, but we were very content that the robot at least worked properly. One problem that we hoped would not occur was a problem that we had with 90-degree turns. At times, the robot would not be able to perform the 90-degree turns depending on which angle that it hit the turn at. Fortunately, this was not a problem on testing day. In terms of design, we felt like ours was sufficient for what we needed to do in this challenge. We were able to put the light sensors close to the floor and close enough together to accurately detect the line. The ultrasonic sensor also fit perfectly on top of our robot and functioned correctly. One thing that we would have changed is the speed at which the robot ran the course. Ours was not the fastest, but also not the slowest. We had more time to work on the code and to test the robot than the other groups, but could not make our robot go faster without missing turns. Eventually we gave up and left it as is. If we were to redo this project, we would definitely focus on the speed and how to make it go faster. One of the takeaways for our group would be pacing ourselves and setting goals with deadlines. We did have more time than the other groups, but I feel like we did not use our time as wisely as we should have. We felt confident in our robot and tried to work on the testing slowly in order to work out kinks. This worked out fine in this case, but we did have many problems with turns and coding the bridge and brick sections. Another takeaway would be to test the robot more often. I feel as if we coded a lot and then tested the robot without testing it piece by piece. An example of this is when we coded the bridge. We did not account for the fact that the ultrasonic sensor can be activated again while doing a 360 under the bridge, and this caused us to rewrite our code and have complications. We thought that it was a problem with the code, so we were confused for a short time. Writing shorter segments of code at a time and testing it could have helped us out in the situation.
Guess what?